All right, we'll give it a minute or so for everyone to join, and then we'll get things started. All right, we'll get started here. So welcome everyone to our second installment of the ongoing webinar series focused around BrainOS. Before we get into things, I'll go over some general housekeeping announcements here. So this presentation will be recorded, and a link to the recording will be made available at a later date for all of those who registered. We encourage you to use the Q&A feature to submit any questions that you have at any point during the presentation. We'll leave time at the end to address any Q&A, and if we run out of time to address all the questions live, we'll be sure to follow up individually through email. As a reminder, this is the second webinar of an ongoing series, so follow us on social for updates, and finally, be on the lookout for a follow-up email with the opportunity to give feedback on this presentation, and you can even vote on what topic you would like to see us present on next. Okay, so here's the agenda for the next half hour or so. First, I'm going to give a brief introduction to who we are and talk a little bit about our mission statement for those of you who may not know too much about BrainCorp. Next, I'll give a quick recap of what we talked about in our kickoff webinar last month before going into a brief reminder of what BrainOS is. Hopefully a refresher for most, but if not, that's okay too. Then I'll hand things over to our main speaker today, Sean Felker, and we'll discuss the key components of safety, security, and privacy as it relates to BrainOS powered robots. So finally, we'll end with some Q&A, so submit any questions you have, and we'll try to get to all those at the end. My name is Shane. I'm happy to be here. I'm a product marketing manager here at BrainCorp. I joined product from the test engineering side of operations here, and excited to be your host today. Sean is our featured speaker. He's our director of safety and brings a wealth of knowledge from his career leading systems and hardware engineering teams. All right, so let's get into it. What's our focus here at BrainCorp? So we believe organizations need a more reliable, sustainable, and cost-effective solution for managing their operations. We envision a world where the lives of people are made safer, easier, more productive, and more fulfilled by the help of robotics. Our mission is to enable organizations and their employees to achieve more by providing solutions that makes our robots more intelligent and useful. So before we get into our topic today, I want to take a moment to look back at what we discussed in our first webinar and remind folks what exactly a BrainOS powered robot means. And by the way, that BrainOS 101 webinar that was recorded is available for everyone to view on our YouTube page under the dedicated webinars playlist. So check that out. So in the kickoff webinar, we dove into the automation journey and highlighted some of the things BrainCorp offers today's data-driven operations and leveraging the power of robotics to make informed decisions, but also how easy it is for the operator to get started automating their workflows using BrainOS. Speaking of BrainOS, so what exactly is BrainOS? Well, at its core, it's a technology platform. Okay, what does that mean? Well, think of it as the foundation for building and running applications. Okay, sure. So what apps are running on BrainOS and what's the value? Well, Clean App is what makes floor care equipment navigate autonomously. That includes software updates with new features, usability improvements, bug fixes, enhanced security, which we'll get into today. Sense App is what enables autonomous inventory management. It supports added payloads on existing robots, pushing data from the edge to the cloud, and then delivering it back down to the customer for actionable insights. And then you have Flow. This includes fleet management tools that enable you to visualize data collected, use data to make informed decisions, support evidence for proof of clean, daily email reporting. This also includes our mobile app, which is one place where users can access training content, quick data points, and even virtual tours. Okay, so at this point, we know what BrainOS is and that our goal is to help you automate operations. But what we want to do is do this safely and securely. So let's unpack this. Our main discussion today is featuring the BrainOS components surrounding safe navigation, data privacy, and functional safety. So Sean, putting you on the spot here, break it down for me. Tweet at us live, 280 characters or less. Summarize what we're going to learn here today.
Well, yeah, thanks, Shane. I am not sure I'll be able to do the 280 characters. If you've seen the output of the test safety tests, the thousands of pages of documents, but I'll do my best here. I think what we're really going to dive into is looking at how safety is built into the entire life cycle, whether it's design up front or even in the operations and response to what we see in the real world. It goes through all those portions of the life cycle. So what we see with robots is that we're in this very, very dynamic environment. Dynamic both in the sense that when the machine is originally trained, that environment that it was trained in could be changing over time if people are rearranging furniture and things like that. But also dynamic in the fact that there's lots of people walking around all the time, people who may not care that much about the robot's success and really just kind of want it to be out of their way. So dynamic in a lot of different ways, which means the robotic system and the autonomous navigation have to be able to respond to that. So you see here, there's a few different layers to that, and I actually I don't know if it was intentional, but a human brain has layers as well that are a lot like what we see in the robot. So there's kind of our frontal cortex, or our higher level thinking, where we plan ahead, we decide where we want to go that day, and why. And that's kind of what you'll see with the navigation portion of things. We're taking a look at those high level decisions, and then the functional safety is more like our reflexes. So we walk around and we plan our days, but then if the doctor comes along and hits us with that little hammer thing, our leg kicks up, and we don't even have to think about it. In fact, even when you're not conscious, your reflexes will still be responding. So I had my kids at the doctor's last week, and we got to do that. And then for the whole rest of the day, I had kids trying to hammer each other's knees. But so reflexes on my mind. But and then we'll also talk a little bit, because it goes hand in hand with the safety of robotics, is what do we do with all that data that we collect as we're navigating around in the world? So that's a quick overview for today.
Well, that was definitely over 280 characters, but we'll let it slide.
Yeah.
So in summary, maybe safety first, safety always.
That's right. Yeah, that's what I meant to say. Yeah.
All right, so let's start at the top. We know robots don't fall asleep at the wheel. Talk a little bit about our autonomy kit and how machines see the world.
Yeah, really stage 0 is that we have to perceive what's going on around us in the robotic system. So we have to get all that info of what's out there and what it's doing and where we are, and into the computer before we can actually act on it. So you can see here a number of the different optical sensors. They're all based on infrared technology. So the sensors send out light rays in the infrared spectrum, and then watch for it to bounce back and determine what's the distance of the closest object. And then you can see where when they're all put together, those sensors are really pointing in all different directions. So no matter which way we're driving, we don't drive backwards. So whichever way we're driving, we've got lots of information coming in about what's out there. And so that's a picture of really the kind of fundamentally step one, and you can't leave it there, but the step one is to make sure you've got appropriate wealth of information coming in. And the sensors you see here are the optical ones. There's ones like encoders to tell us how fast we're going. So there's even more than what you see here that's part of the kit, but these are ones that are easy for us to kind of see what, take a look at how the robot sees the world in a somewhat similar way we do. We see light. We have to turn our head. The robot doesn't have to, because it's got sensors pointing in all directions.
Absolutely. Yeah. So, okay, what I gathered from that, sensors are how the robot perceives the environment. And so software takes that information and uses it to navigate. So the software is the brain. Tell us how software updates improve security.
Yeah, and it actually also improves safety as well. So I'll talk about both of those. And you're right, we get a bunch of information in. Software is what helps us make those logical decisions on what do we do with that information. And so, like I had mentioned a little while ago, we try and build in safety and security throughout the entire life cycle, and this pathway of software updates is kind of that critical link where that's nice if you're always thinking about how your robot is doing out in the world, but unless you have a pathway and a mechanism to actually respond to that and make changes based on that information, it's not going to be as helpful. So the software updates really allow us to, as we gather information, learn more about those dynamic environments that we're operating in. We can either enhance performance. There's lots of reasons to update the software. I think people often think about, oh, cool new features, which is always great. But what it also allows is, as everyone knows, the world of cybersecurity is kind of continuously evolving, and people are smart and they find interesting new ways to take advantage of computer systems. And so we can continuously update for those reasons, but also, like I said, there's learnings about environments and the combinations of factors that we might see, as we've, I think maybe you mentioned at the beginning, or maybe last week, but we've been out there for 9 million hours with these robots, and so we've gotten to see a lot of interesting combinations of factors and how that plays out with the robotic system. So we have these mechanisms then to say, well, what should we do about that, and can we make it better, make it safer, more secure, and that's a really neat feature. I always say, imagine if when they invented anti-lock brakes, you could click a button and all the cars that were already on the road got anti-lock brakes. So software is kind of neat in that way, that unfortunately you can't update hardware over the air like you can software, but there's a lot of good improvements you can do with that software feedback loop.
Yeah, absolutely. As we learn more about our system and the world it operates, I think that's one of the key advantages of Brain, is that we take all that information and put it into our product and through software updates.
And I should mention too, looking at this middle image here about, because people think, oh, software updates, some kid is in his garage and just one night decides to push some new code that he's created, and that's not what we're talking about here either. So there's lots and lots of systems built in for that testing that gates those software releases. So whether it's the automated testing, people write code to test the code, and so that happens, millions of lines of code executed automatically as we build the new software versions, as well as integrating that software on real machines and walking through all those tests. So there's, some people get a little worried when you say, oh, well, we can just update it. Well, how do you make sure those updates are also well controlled? And so we've got lots of systems in place for that as well.
Yeah, it helps that we do have a world-class QA organization here, so nothing to worry about there. So that brings us to our next point here, is like, what if something fails? Like, how do I know on a day-to-day basis that I can trust the robot will perform as it should.
Yeah, and I think you'd be hard pressed to find a company that says, well, safety is not our top priority, or maybe it's our third or fourth. Everyone says safety is their top priority. Well, what does that mean, and what are we doing about it? So there's this term called functional safety, which I always have to explain, because people are like, well, yeah, it should be safe, right? Why do you add this weird functional safety thing? And that's the term that I would say, that those reflexes that I talked about. So there's layers of the system, and you can think about behaviors or functions of a robotic autonomous system. For example, someone steps in front of it, it should stop. And that's actually not too hard to do if you've got good perception of the world. Someone could just say, if I see something, stop. All right, that's a safe behavior. We definitely need that. But what are the processes that you go through to make sure that over those 9 million hours, that every single time it's going to do the same thing, even when there are inevitable failures? And so the whole discipline of functional safety, it's defined by a set of standards, but it was put in place to look at what happens when a system, when the hardware inside of it or various different software pieces are not acting as they were intended to. And with hardware, all hardware will eventually wear out and have these random failures. Capacitors, resistors, they'll burn out. And so what does your system do to respond when it senses that those types of things are going on inside of it? And so the discipline of functional safety starts out with quantifying all the risks. What are the definitions of the functions that you actually need to perform? How do you need redundancy in those systems? Do you need self-diagnostics? And so the design of the system walks through all of those different aspects. All the testing that I mentioned fits under that. Every function that you have defined as safety critical needs a corresponding test to demonstrate that it's performing as you intend it to, or even performing under failure conditions as it's intended to. And so I think before I got into safety, I always wondered, if you can only test a few thousand hours in a lab, how do you scale that up to millions and millions of hours when you get lots of products out there? And this discipline is what helps you take that scaling leap from, we can test a lot in the lab, but that's just a tiny portion of the amount of time that our machines will spend out in the real world. And this very meticulous discipline is what helps you bridge that gap.
Yeah, absolutely. And I think, for me, the big take home point here is just that confidence that, the note we have there at the bottom there is like the confidence that thousands of vehicles stop every time for millions of obstacle exposures there. And so I get why we, BrainCorp, implement something like functional safety, but why does like a third-party recognition matter? Is this just like a feather in our cap? Like, let's say I'm thinking about buying a robot. I don't care too much about compliance, maybe, or maybe I don't even know much about it. Like, what's the advantage of all this?
And that's a really good question. You turn over your power supply for your computer, and you'll see all these little UL, CSA, Intertech markings. What do they all mean? Sounds like a bunch of paperwork, and so that's definitely a question I get. In fact, when we got recognition, I was like, should I get a tattoo? It was so hard to achieve, so that I will be UL recognized. I did not.
It's
My
like
wife,
the Olympians, getting
right,
the things
right. My
tattooed.
wife was not, into that, so didn't do that. But yeah, it's a great question, because at the heart of a standard is really it's a list of requirements. So if I go through and meet those requirements, what's the advantage of having this little stamp that says, and what do you have to go through to get that stamp? And those types of things are actually not super well known, and a lot of people think, oh, UL is some government agency or something, and it's not. It's really a third-party test house that is is being, you basically ask them to come in as an independent third party and to take a look at what you have done and validate that you have actually walked through all of the clauses of a given standard. Um, and so, I mean, why even meet a standard, I guess, is the first question. And the way that these standards are written, there's, committees that are formed with lots and lots of years of experience for people in the actual industry using the products that are associated with those standards. So there's a huge advantage to having lots of people with lots of experience get together and say, what are all the important things that we have seen in our careers that should get piled together here so that people who are going to make these products don't miss anything. So that's one advantage of even following a standard, because lots of people have done lots of work. Let's take advantage of their knowledge. And then for us, getting that formal third-party recognition, of course, it's not, if everyone was perfectly honest and no one ever bent the rules or anything, then no one would ever need that, I think. But it's helpful for us for a couple of reasons. One, internal validation. The first product that we put out into the world, I wanted to have a third party who came in and said, yes, you, sir, have followed the standard well. And so there's, an internal impetus to have someone else look at what you've done and say, yes, this is what is it's intended to be. And then, as well as having that mark is helpful to help show other people who are either going to buy or integrate our product into their products. They now have an additional layer of confidence that someone else besides just Brain, of course, the conflict of interest thought is like, well, of course you want to sell us something, so you're going to say it's great. This is somebody else who's independent and won't make any money off your product, that has come in and said, we also validate it. So I do think it's valuable, especially for a company newer in the world than some other companies like Brain.
Yeah, absolutely. I mean, to me, it's just generally better products, or better quality, just more robust product. So a lot of what we discussed involves the use of data collected by the robot. How do I know this data isn't being seen by a competitor? Thinking if I'm the customer here. So tell me about the data lifecycle.
Yeah, and it's actually the first step, an important step, is to realize that we're encountering people with our robotic system, both people and organizations who have a very different perspective on what information they care about. So if you imagine someone from the public who's walking by the machine, they may care about their personally identifiable information, or things like, well, where is this thing looking at where I am at what time, and is it creeping on me? Whereas, an organization like a big retail store may care more about, well, you collect all this data, and then of course you want to give the data back to those folks in meaningful ways, so it can help them understand how much has been cleaned, or in the case of Sense, actually get images back and those types of things. But how do they know that some other retail company that also has a robot doesn't see how they've laid out their store and what strategies they've used? So those different groups that encounter the robot all have a wide variety of different concerns and cares about what data we're collecting and how it gets used by the robot. And so for the individual robot on the machine, as well as when you look up at kind of the aggregated data, it's really all focused on the performance of the actual functionality of the machine. And we actually don't want to collect data that is personally identifiable, but like I said, we do collect things that pieces of information that we want to forward to those who care about it, who are paying for our services. And so we've got lots of systems on the robot, like encryption, all the security for on robot. But I think it's then also important to talk about, okay, so but don't you send some information off the robot, which is I guess there's multiple dimensions of this data and privacy equation.
Absolutely, yeah. I mean, ideally, everyone would already have a blurred face, so we wouldn't have to do that on the back end. But
That'd be great. Yeah, if
yeah.
everyone could do that,
Well, I don't know
please.
about great, but yeah, easier for us. Okay, so I understand, what you just mentioned, the mechanisms of how we collect data and use it on one robot. But we have over, like 20,000 robots in the field. How does the scale of data factor in here?
Yeah, and the more data you get, the more powerful that data is. And so when I always am just blown away in a good way by when we do end up saying, okay, this release of software is ready to go. In 24 hours, we've got 40,000 hours of usage or whatever that we can take a look at, which is incredibly helpful to understand that everything's functioning as we had intended it to. As well as looking at just insights about things like performance. Well, we keep seeing it get stuck in this type of situation. Is there a way we can make sure it doesn't get stuck and perform better? So more data and looking at trends in those data is how engineers get their robots to perform better and better. So there's really key insights that you can gain, but then the same conditions apply, where you've got to learn and know what the people care about whose data you're collecting, and how to make sure that it stays in the right places with the right access. And again, the goal of our robots is to really drive the functionality that we're providing. And so if I could sum up our privacy, data security in one line, is that, yeah, the data that we get is focused on the insights, not at all on the personal information or selling. People are always worried about, am I just going to get spammed and all those types of things. But we've compartmentalized the data, made it, the access controls are there, whether it's on the robot itself or you've got information in a cloud storage. And so we take both of those at the same level of seriousness. Small data on the robot, big data in the cloud.
Yeah, absolutely. I know people tend to see the cameras, they're worried about surveillance and stuff. But I think the take-home point here is that, that data is used for autonomous navigation, operational support, to make the product better, and then just assistance, when we do run into issues in the field where, the robot needs help. So we leverage that data to help it out. Well, thanks, Sean. I'm going to keep you around here for a little while longer. I know we're running close to time here, but I want to leave a little bit of time for questions. Just as a reminder, in future webinars, we'll take you through what an automation journey with BrainCorp looks like, where we'll take a deeper dive into other features and tools. So if you want to, you can scan that QR code with your phone, and it'll bring up the Contact Us page on braincorp.com. And those responses are piped directly to our team here. So feel free to reach out. Okay, let me take a look and see what questions we had come in here. All right, the first question, let's see. What is the smallest size thing your robot will see?
Yeah, this is actually I love this question, hate this question, and it comes in quite often if we do experience something interesting in the world where it's pretty clear people understand if you put a fishing line in front of the robot, that might be difficult for it to detect. So like, hey, what's the smallest thing it can see? It's a super reasonable question. The interesting thing is that if anyone who's doing autonomous navigation gives you like a single 10 centimeters by 10 centimeters by 4 centimeters answer, they're lying to you, or they're at least giving you a summary that is probably too generalized to be functional. So like you saw with all those sensors information coming in, the different angles and the different materials that a object has affect, you know, what sensor it's seen by, and therefore what resolution and what you know, how the system can perceive it. So I think what I usually like to say is what we validate is that there's absolutely no gaps that would be the size of even small humans. But then, you know, as you get smaller than that, we can almost always detect things that are in that 10 centimeters range. But then again, as you get more and more complex movements, the materials of the objects and all of those things, you can get some interesting combinations, and we're always honest about that. And so if anyone ever gives you an answer that's just a single number, you know, that's inaccurate. It's the real world is much more complex than a single answer to that question.
Good to know. Guys, we are at time here. I want to be respectful of everyone's rest of the day. And Sean, thanks so much for being our main presenter today and giving us all of your robotic knowledge here. We're going to wrap things up. I just want to remind everyone that you have the ability to submit questions in the chat, and we could still email you the responses to those later. But thank you, and we will see everyone next time.